Okay, now we're going to take a look at parabolas. We've already graphed parabolas that opened up and down, but now we're going to look at parabolas in a more general sense. So we'll see parabolas that open to the left and open to the right also. So what we want to focus on is how the equation of the parabola and the focus, directrix, vertex, and axis of symmetry of the parabola all relate together. So we are going to get a little bit more vocab here than we were used to the first time we looked at parabolas that opened up and down. So earlier we studied parabolas where y was a function of x. So those were quadratic functions where y equaled ax squared plus bx plus c, where a, b, and c were constants, and a was not allowed to be 0 because we needed the x squared term. And now we're going to study parabolas in a more general sense, and some of these that we look at will not be functions. Y will not be a function of x. So those would be the parabolas that open to the left and open to the right. So we're going to get a more general definition of a parabola now. So a parabola is the set of all coordinates or points on the coordinate plane that are equidistant from a fixed line called the directrix and a fixed point that's not on that line called the focus. So that sounds really complicated, but if we take a look at a picture, it'll make a lot more sense. So we've got, according to the definition, we need a line and a point that's not on the line. So I've drawn this vertical line right here. So I've got this line, it's a vertical line, and it's called the directrix. So there's our fixed line called the directrix. So this line's not moving anywhere. It's just a vertical line called the directrix. And then we need a coordinate or a point that's not on that line. So I've got this point right here, this blue one, and that's called the focus. So we've got a point that doesn't move, a line that doesn't move, and that point is not on that line. So by definition, what a parabola is it's all of the coordinates that you can come up with that are the same exact distance from this blue dot and this red line. For example, if I go 2 units away from the line and 2 units away from the focus. So this dot right here, that dot right there that I just colored in, that dot is exactly the same distance from the line and that dot called the focus. So let's just say that's distance 1, and this is exactly the same distance, distance 1. Now we know that point is called the vertex, and it still is called the vertex, so that's not going to change. So this coordinate right here is still called the vertex. Okay, so all we've got is one dot now that is the same distance away from the focus as it is the directrix. So what about another dot? So if I pick this coordinate, say right here, according to the definition of a parabola, for this to be a coordinate on the parabola, the distance from that to the focus, we'll just call that distance 2, it should be the same distance away from the line, so we'll call that distance 2. So those should be the exact same distance. And by the way, um, the distance from a point to a line has got to be perpendicular. So this distance and this distance have to be exactly the same. If they're exactly the same, then that coordinate is on our parabola. So even if I pick a point, say, way down here, so we pick that coordinate. Let's get a little bit away from our word vertex. So let's say I pick this coordinate right here. So this distance, we'll just call that distance 3. That should be the same distance right here. We'll call that distance 3. So they should be the exact same distance away. Now mine might not look like it's the exact same distance because I didn't draw it perfectly. I tried to draw it pretty close. But this distance right here and this distance should be the same. And that should be true for any point that's on the parabola. So if you should be able to pick a point on the parabola, and then from the focus So from the focus to that point and that point to the line, that should be the exact same distance. So that's what they mean by this definition up here. So it's the set of all points are the same distance from a fixed line called the directrix and a fixed point not on that line called the focus. And then all those points together create a parabola. The same shape we've seen before. It's that U shape that we saw before. But now we're going to have parabolas that not only open up and down, but left and right. Because we're not worried about them being a function. We just want the parabola itself. All right, so there are four equations that we have to be familiar with. And I know you're thinking four, that's a ton, but it's really not that bad. So let me see if I can help you out. So two of them we've already seen before, but they're going to look a little different. They're written differently to help you out, not to confuse you. Okay, so we still have parabolas that open up and open down. Now the equation looks a little different, but follow me here. It's really going to end up being not that bad at all. So we've got this A, and if A is positive, then earlier when we studied parabolas, we said if A was positive, the parabola will open up. Well, that's still true. So we've got this A right here. We got this positive 4. We've got this A. If A is positive and 4 is positive, this whole thing's positive, we're going to open up. Whereas down here, we've got a negative 4A. So if A, after you plug in A, or whatever A is, if this number out front ends up being negative, like we're showing here, then we're going to open down. So it's very similar to when we first did parabolas, where you just kind of check this number, and if this number was positive or negative, it told you whether it opened up or down. It's going to be very similar here. And then when we very first studied parabolas, we said the vertex was at HK. Well, guess what? HK is still the vertex. So for all four of these equations, HK is still the vertex. So that's going to be easy to remember. Well, how do you remember which ones are up, down, and which ones are left, right? Well, it's pretty easy. When we very first did parabolas, we learned y equals ax squared plus bx plus c. And if you remember, x was squared, and those opened up and opened down. So when we very first did parabolas, we had parabolas that opened up and down, and it was the x term that was being squared. We'll go look at our four equations. The ones that open up and down, it's the x term that's being squared. So we have x and it's being squared. We have x, it's being squared. So those are the ones that open up or down. So that means the other two, where y is being squared, they're going to open left or right. And the way you figure out whether they open left or right is, again, you look at this number out in front. If this number is positive, then it opens to the right, and if this number is negative, it opens to the left. So positive numbers are to the right on the x-axis, and negative numbers are to the left on the x-axis. So if this number sitting out front is positive, the parabola opens to the right, and if that number is negative, the parabola opens to the left. So the equations look like we're trying to make this more complicated than it needs to be, but believe it or not, the it's actually set up this way to try to make it as easy as possible. So HK will still be the vertex, and it's going to work the same way, where when you actually look at the equation, H and K will be the opposite sign of what's in the equation. So if it's minus H, it'll be a positive K. If it's plus H, it'll be, or sorry, we're talking about H there. So if it's a minus H, it'll be a positive H. If it's a plus H, it'll be a negative H. And same thing for K this time around. So if it's a negative K, it'll be a positive K, or if it's a plus K, it'll be a negative K. So it'll be the opposite sign for the vertex. And then that just leaves us this A that's sitting right here. So that A is the distance from the vertex to the focus, or it's the distance from the vertex to the directrix. So I'm going to point that out in every one of these that we work with, but if we go back to the picture that we've already drawn, This distance right here that I labeled D1 earlier when I was explaining the definition, that distance is going to be the A that's in our equation. So the distance from the vertex to the focus, or the vertex to the directrix, it's this distance right here from the directrix to the vertex to the focus. That distance is A in the equation. So that A is very important. So the H, A, and K are key to this whole thing. Alright, so let's give this a try. So the vertex of a parabola is -5, +1. So let's draw a picture. So -5, +1. So -5, 1, 2, 3, 4, 5, +1. So that's the vertex. And then the directrix is y equals -2. So -2, that's a horizontal line. So that's D, that's the directrix. And then this is our vertex. So our vertex is above the directrix. So that means our parabola, I don't know exactly how to graph it, but our parabola is going to have to open upwards because the parabola always opens away from the directrix. The parabola doesn't ever cross or intersect the directrix. It always opens away from it. So basically what they've told me is I have a parabola that opens up. That's what I know based on what they've told me. Well, in this example, we just want to find where the focus is. So the focus, I can actually find it really easy based on what they told me, because as we just talked about, the distance from the directrix to the vertex is A. So for us, um, that distance is a distance of 1, 2, 3. So A is 3. And then to find the focus, I just go that far away from the vertex. So I just go 1, 2, 3, and then that should be the focus, because that has to be a distance of A also. So that's a distance of A. So that means my focus must have been, let's see, -5. And then instead of going up 1 to the vertex, we go up 1, 2, 3, 4 to the focus. So I find that to be much easier when you actually look at a graph real quick. You don't have to draw an elaborate graph, just draw what they told you, and you can easily figure out um, the distances that we need. Those are both a distance of 3 by looking at that graph. So the focus must have been at -5, +4. All right, let's look at another one. Let's find the equation of the parabola that has a focus of 0, -2, and x equals 3 as its directrix. So again, I'm gonna graph this to help. Looking at the graph makes this a lot easier. So 0, -2, and x equals 3 as its directrix. So here's the y-axis, x-axis, and let's see, x equals 3 is the directrix. That's a vertical line through 3. And then its focus is 0, -2. So that's its focus. Well, again, I can tell that this parabola opens to the left, because if that's the focus, then when I go to graph this, I don't know exactly where to graph it just yet, but it's going to have to look something like this, because the focus, The parabola has to open away from the directrix, and it always opens around its focus. So it's going to open to the left. So based on what they've told me, I know it opens to the left. So the parabola opens left. So if it opens left, then my equation must be y minus k squared equals negative 4a x minus h. So I know it opens left, so my y term is being squared. And then since it's opening to the left towards the negative numbers, I need the negative 4a one. All right, well, this is the focus, and this is the directrix. So the vertex would have to be halfway between them. So from the focus to the vertex, that's a distance of a, and then the vertex to the directrix, that's a distance of a. So the vertex is halfway between the focus and the directrix. So this coordinate right here, the vertex will just be the midpoint of those two. So this coordinate is negative 3, 1, 2, 3, negative 2. And I already know what my focus is. My focus is 0, negative 2. So my vertex is going to be the midpoint of that. That's going to be my vertex. So let's find the vertex real quick. So the vertex is going to be the midpoint. So it'll be 0 plus negative 3 divided by 2. Negative 2 plus negative 2 divided by 2, which gives me negative. Oh, whoops, that was positive 3. Suppose it hoped if I had my sign right. Go away. So that was positive 3. So this will be positive 3 halves. And then negative 4 over 2 will be negative 2. So it's going to be at 1.5 and then at negative 2 is my. So that's H and that's K. And now I also know what A is for our equation. So for A, it's going to be this distance, which is a distance of 1.5 or 3 halves. So that's a distance of 3 halves. So that's going to be A. Be 3 halves. So let's just go plug everything in. So it'll be y minus k, negative 4 times a, and then x minus h. So we end up with y plus 2 squared, and then negative 6, x minus 3 halves. And then there's our equation. We'll just go ahead and leave it like that. We won't solve for x or y. We'll leave it as it sits. All right, so in the next example, let's go ahead and just graph the parabola we just found. So our parabola was y plus 2 squared equals negative 6, x minus 3 halves. And we want to graph that. All right, so to graph it, we need the vertex. We're going to need several things, so we'll talk about how to graph it real quick. So remember, this was y minus negative 2 squared equals, and then we had a negative 6 there. So to see what a was, let's pretend we didn't know what a was. So if you didn't know what a was, you just take a 4 out. So basically, negative 6 equals 4 times what? Or, yeah, 6 equals 4 times what? We know the negative's there because it opens to the left. So 6 equals 4 times what? So a must have been 6 fourths, which is 3 halves. So that's how we would know it's 3/2 if we didn't know it from doing that earlier problem. And then, so looking at this equation, this is, and then right here is, that's our H, and then there's A. So there's all the stuff that we need. So all the important stuff, H, A, and K. So our vertex is 3/2, -2, and then A is 3/2. And with that, we can graph this parabola pretty easily. All right, so we know that it opens to the left because y is being squared, and then we have a negative term out front. So y-axis, x-axis. So let's plot our vertex, which is 1.5, -2. That's our vertex. And then to get the directrix, you go a distance of a from that. So you go another 1.5 to get to 3, and that has to be the directrix, which I'll just use a capital D. And then to get the focus, we just go 1.5 in the other direction to get the focus. And then now we just need to graph the parabola. So there's lots of ways we could do this. We could do a T-chart if you wanted, but the fastest way, the easiest way, in my opinion, to graph any parabola, is to use what's called the latus rectum. So what we're going to do is we're going to go a distance of 2a above and below the focus. So we're going to go 2a above and 2a below. So if we do 2 times a, that would be 2 times 3/2, which would be 3. So we're going to go a distance 3 up and a distance 3 down. And then our parabola will just be a U shape that goes through those. So our parabola is going to look like that. And then this line segment right here, so this line segment that I've got right here, it's not really part of the parabola, but it helps us graph it. And it has a name. So first off, this distance right here, that's a distance of 2a. And then this right here is a distance of 2a. And that line segment is called the latus rectum. It's not actually part of the parabola. It's a line segment that passes through the focus, and it's parallel to the directrix. So basically, once you get the directrix and your vertex and your focus, you get those three things, all you got to do is figure out what 2 times A is. You go that much below the focus, plot those 2 points, and then you've got 3 points on your parabola that lets you connect up your parabola really quick. If your parabola opens up and down, Remember, it just has to be parallel to the directrix. So you just go 2a to the left and 2a to the right. And then you have 3 points to graph your parabola really fast. Okay, so in this next one, we're going to find the vertex, focus, directrix. We're going to find basically everything we'd want to know about this parabola. So this time they give us the equation. But you'll notice it's not written in standard form. So the equation as they've given it to us isn't very helpful because it's not in standard form. So what we're going to do is we're going to put the y squared and the y term, we're going to put those next to each other, and then we're going to move everything else to the other side. And then the y squared and the y, we're going to complete the square. And then this is now a perfect square trinomial, y minus 1 squared. We'll add the 1 to the other side to get negative 24. And then we'll factor out 12. And then 12. So basically 12 equals 4a. We want that to be 4a. So a must have been 3. So it'd be 4 times 3 times x minus 2. So we've got everything we would want. We've got h, we've got, and we've got k. So we got everything we would want. So let's start with the vertex. So the vertex is hk. So it'd be 2, 1, right? It'd be h, and then this would be our k, and this is our a down here. We also know that since it's y squared and 4 times 3 is a positive number, we know it's going to open to the right. It's going to open to the right. So what else did I ask for? The focus. So the focus, remember our parabola is opening to the right. So if that's the directrix, then we're going to have a vertex, and then we're going to have a focus, and it's going to open like this. So to get my focus, remember it's just a distance of A from the vertex. So it's just going to be 2 plus A, comma 1, which would just be 5, comma 1. Then what else do they want? They want the directrix. So my directrix, well, it's got to be vertical because I'm opening to the right, and it's the distance. It's also a distance of A from the vertex. So it's just going to be x equals, and then we'll go 2 minus 3 because we got to go 3 in the other direction, and we get x equals negative 1. And then they want the axis of symmetry, which that's no big deal. That's just this line that passes through the vertex. We've been doing that for a while now. So that would be y equals 1. So we got everything they asked for. We've got the vertex at 2, 1. Our focus is at 5, 1. Our directrix is at x equals negative 1. And then our axis of symmetry is y equals 1. So we got everything we would want. And then it says graph the curve. Well, I don't have enough room to do that, so I'll just have to scroll down, and you'll just have to bear with me as I scroll back and forth. All right, so our vertex is at 2, 1. So that's our vertex. And then the focus is at 5, 1. It's the focus. And then my directrix has to be the other direction. So don't forget how this works. This has to be a distance of A, and this has to be a distance of A. You got to go a distance A from the vertex to the focus and the vertex to the directrix. Okay, and then to graph it, like I said, let's just use the lattice rectum. It's easy. So 2 times A would be 2 times 3, which would be 6. So all we're going to do is go 6 above and 6 below. So 1, 2, 3, 4, 5, 6. So not going to make it. Going to have to move my graph. All right, so we're going to have to go 6. 1, 2, 3, 4, 5, 6. And then 1, 2, 3, 4, 5, 6. And then I can draw my U shape through those. So here's the lattice rectum again, right there. Again, that's not actually part of the parabola. So, but it does help us graph it. So this right here, that's a distance of 2a, and then this right here is also a distance of 2a, which is 6 for us because a was 3. So there's a graph of that parabola. So basically only the curved U shape is the parabola. Everything else is just there to help us graph that parabola. Okay, last one. So let's find an equation of the parabola that has a vertex of 4, 2 and a directrix of y equals 5. So again, a picture helps quite a bit. So y equals 5 is the directrix. It's a horizontal line through 5. And then our vertex is 4, 2. So that's our vertex. So right off the bat, I can figure out A. So A right here. So A, when we look at the graph, is 1, 2, 3. A is 3. And we already know the vertex, which is 4, 2. So that's H, that's K. Not only that, I also know that this parabola has to open downward. Parabola's got to open downward. Again, because the parabola opens away from the directrix. So, since it opens downward, it'll be x minus h squared equals negative 4a y minus k. So it'll be x minus 4 squared equals negative 4 times 3 y minus k. And then the only simplification we're going to do is go ahead and write that as negative 12. And then we'll just leave it like that. We won't solve for x or y. We'll just go ahead and leave it like that. So we can write the equation of a parabola pretty quickly as soon as we figure out what a, h, and k are. So we just need to know a, h, and k.